difference between abstract class and interface object-oriented programming, OOP, is built on the idea of organizing software using real-world concepts such as objects, classes, inheritance, and abstraction. Among these concepts, abstraction plays a very important role in designing large, flexible, and maintainable applications. Two major tools used to achieve abstraction in programming languages like C# and Java are abstract classes and interfaces. Though both are used to hide implementation details and show only essential features, they are not the same. Many beginners get confused between abstract classes and interfaces because both appear to perform similar tasks. However, in real-world software development, they serve different purposes and are used in different design situations. An abstract class is a class that is declared using the abstract keyword and cannot be instantiated directly. It is mainly used as a base class from which other classes inherit. An abstract class may contain abstract methods, which do not have a body, and also non-abstract methods, which have complete implementation. This means an abstract class can provide both rules and ready-made functionality to derived classes. It acts as a partially implemented class. The main idea behind an abstract class is to provide a common base that shares behavior among related classes. When multiple classes have similar features, an abstract class allows code reuse and avoids duplication. On the other hand, an interface is a completely abstract structure that defines only method declarations, properties, events, or indexers without providing any implementation. An interface is declared using the interface keyword. It represents a contract or agreement that a class must follow. When a class implements an interface, it must provide implementation for all the members declared in that interface. An interface does not contain method bodies, constructors, or instance variables. Its main goal is not to provide functionality, but to define what a class must do. In simple words, an interface specifies capabilities rather than behavior. One of the most important differences between abstract classes and interfaces lies in method implementation. An abstract class can have both implemented and non-implemented methods. This means it can contain full logic for some methods and leave others to be implemented by derived classes. This flexibility makes abstract classes suitable when developers want to share common code across related classes. In contrast, an interface cannot contain method implementations, except default methods in modern versions. Traditionally, interfaces only declare method signatures. Therefore, interfaces enforce uniform behavior, but do not provide reusable code logic. Another major difference is related to inheritance. In C#, a class can inherit only one abstract class because multiple inheritance of classes is not supported. This limitation exists to avoid ambiguity and complexity in method resolution. However, a class can implement multiple interfaces at the same time. This is one of the strongest advantages of interfaces. Through interfaces, C# supports multiple inheritance indirectly. This feature is extremely important in large applications where a class needs to follow multiple contracts such as logging, security, serialization, and communication at the same time. Abstract classes are used mainly when there is a strong is-a relationship between the base class and derived class. For example, a car is a vehicle, a dog is an animal, and a teacher is an employee. In such cases, abstract classes work best because they represent hierarchical relationships. Interfaces, however, represent can-do behavior. For example, a class can implement ironable, iswimmable, or iprintable. These behaviors may apply to unrelated classes. A machine, a human, and an animal can all implement ironable, even though they do not belong to the same class hierarchy. Another important distinction is data storage. Abstract classes can have instance variables, fields, and properties that store state information. This means an abstract class can maintain data. Interfaces cannot maintain state because they do not allow instance variables. Interfaces can only contain constants. As a result, abstract classes are more suitable when shared data is required among derived classes, whereas interfaces are used when only behavior specification is needed. The concept of constructors also separates abstract classes from interfaces. Abstract classes can have constructors. These constructors are called when a derived class object is created. Constructors are useful for initializing variables and setting default values. Interfaces cannot have constructors because they cannot be instantiated and do not contain implementation logic. This makes abstract classes more powerful in scenarios where object initialization logic is required. Access modifiers are another point of difference. In an abstract class, methods and variables can have access modifiers such as private, protected, internal, or public. This allows developers to control accessibility and encapsulation. In interfaces, all members are public by default, and access modifiers are not allowed. This restriction ensures that interfaces act purely as public contracts without hidden logic. When it comes to performance, abstract classes are slightly faster than interfaces. This is because method calls in abstract classes are resolved earlier than interface method calls. However, in modern systems, this difference is usually negligible and should not be the main reason for choosing one over the other. Design clarity and maintainability are far more important than minor performance differences. In real-world application design, abstract classes are commonly used in frameworks and base libraries. For example, in .NET, classes like Stream, DBConnection, and Controller are abstract classes. These classes provide base functionality and expect derived classes to complete specific behaviors. Interfaces, on the other hand, are widely used in dependency injection, service-based architecture, and enterprise-level systems. Interfaces allow loose coupling, making applications easier to test, extend, and maintain. Another critical design difference is tight coupling versus loose coupling. Abstract classes tend to create tighter coupling because derived classes depend on base class implementation. Interfaces promote loose coupling because they define only what should be done, not how it should be done. Loose coupling is a fundamental principle of modern software engineering and is essential for scalable and testable systems. That is why interfaces are heavily preferred in large enterprise applications. In unit testing, interfaces play a vital role. Mock objects can easily be created for interfaces, making testing simpler and more reliable. Abstract classes can also be mocked, but it is more complex due to existing implementations. This makes interfaces a preferred choice in test-driven development, TDD. From a design perspective, abstract classes represent inheritance of behavior, while interfaces represent inheritance of responsibility. Abstract classes say, "You are this type," whereas interfaces say, "You must follow this rule." This conceptual difference helps developers decide which approach to use during system design. In practical scenarios, abstract classes are used when multiple classes share common logic, default behavior, and data. Interfaces are used when different classes, possibly unrelated, need to follow the same method structure. For example, payment systems may implement interfaces such as iPayment Gateway, allowing credit card, UPI, PayPal, and net banking systems to follow the same contract while having entirely different implementations. Modern programming practices often combine both abstract classes and interfaces. An interface defines the contract, and an abstract class provides partial implementation of that contract. This hybrid approach gives the benefits of both flexibility and code reuse. In conclusion, although abstract classes and interfaces both support abstraction, they serve different purposes and should not be used interchangeably. Abstract classes are ideal when there is a clear inheritance relationship and shared behavior among classes. Interfaces are best when defining contracts, enabling multiple inheritance, and achieving loose coupling. Understanding the difference between abstract classes and interfaces is essential for writing clean, scalable, and professional quality code. A good developer does not choose between them randomly, but selects the appropriate one based on design requirements, future extensibility, and system architecture.